Hey guys, starting to take a look here at what's going to be the final section that we look at this year. And we are going to split it up into 2 days here. So this should take us through the end of the week and through the end of the year then. So we're looking at 6.4, this idea of rational exponents, so fractional exponents. So we've seen whole number exponents or integer exponents, or we've seen zero as an exponent. We've seen negative exponents or integer exponents, as I said before. Um, but now we're going to take a look at what do fractional exponents mean? How do we interpret those? And no surprise, that's going to involve radicals or square roots or cube roots. All right. A couple things here. So it says you can write a radical expression in an equivalent form using a fractional exponent. All right. In general, and again, I know this is a little hard to read, but this is the nth root of x. All right. So that could be if n was a 2, that'd be the square root of x. If n was a 3, that'd be the cube root of x. But we can take any radical expression and write that using a fractional exponent. If I have the nth root of x, that is x to the 1 over n power. All right, so just a couple real quick examples here. So if we have the square root of 36, so again, a couple things to realize here. Maybe one thing to realize: if they don't put an index there, that is understood to be a 2. All right, they don't always write that in, especially if that's or only if that's a 2. All right, so I can rewrite this as 36 to the 1/2 power. The square root of 36 I can write as 36 to the 1/2 power. The cube root of 64 is 64 to the 1/3 power. And the fourth root of 16, yeah, you guessed it, that is 16 to the 1/4 power. All right, so if you have an nth root of any expression, all right, now these were just numbers here, you can write that as a fractional exponent by simply putting 1 over, the exponent would be 1 over whatever that index is. All right, so if we were asked to simplify these things, so this is 216 to the 1/3 power. Now again, you could type that in your calculator if you want to, but to transfer it back into a radical expression, 216 to the 1/3 power is just another way to write the cube root of 216. Now, if we were in my classroom and I had all those posters up, that would be pretty easy to see, what number, because again, what they're asking is what number raised to the third power equals 216, all right? But since you're not there, your calculator will actually do this for you, all right? So if I hit math, and then you see the fourth option down there is the cube root, all right? So if I hit 4, that's the cube root, and then I can type in 216, and so it's going to find me the cube root of 216, which is 6. All right, so 216 to the 1/3 power is just 6. This, again, a little bit hard to read here, but that's 7 to the 1/2 power times 7 to the 1/2 power. Well, let's write these in radical form. So 7 to the 1/2 power is just the square root of 7. Again, we don't write that 2 in there. If you want to, it's not wrong. I wouldn't count you wrong for it, but it's not needed. And again, 7 to the 1/2 power. So really what we're doing is the square root of 7 times the square root of 7. And since these are both square roots, I can multiply those and make that the square root of 49. And then the square root of 49, you can do that on your calculator. Hopefully you realize that that's just 7. So 7 to the 1/2 power times 7 to the 1/2 power is 7. All right, just plain old 7. Oh, that's going to come in tomorrow. All right, so hold on to that. And then finally, this is 5 to the 1/4 power times 125 to the 1/4 power. Again, I can write those in radical form. So that would be the fourth root of 5 times the fourth root of 125. Since they're both fourth roots, since these indexes are the same, I can just multiply those. And 5 times 125 is 625. So that is the fourth root of 625. You might know that, but just in case you don't, we can also use our calculators for this. Now, since it's a fourth root and not a cube root, If I hit my math button, you see they don't have a rule here for the fourth root, but they have number 5 here as an xth root, so I can do whatever I want. But the first thing I got to do here before I get to that is understand that I'm going to do the fourth root. I have to type that 4 in first. So if I type in 4, and now I hit my math button and I either scroll down or just choose option 5 there, and notice it automatically put that 4 up in the index. So for anything other than a cube root, you kind of have to, hit that index before you get to that math menu. But now I want to find the fourth root of 625. And it's 5, all right? Which means 5 to the fourth power is 625. So you can simplify things with fractional exponents by writing them in radical form. All right. Now, the other thing, all right, to look at here, all right, is, and this kind of comes right from here, where did this 1 come from? Well, it really came from, this is really, I could write this as 36 to the first power. I could write this as 64 to the first power. We don't put that exponent in there, but it's there. And so this next part, you notice that the numerator is the exponent of your radicand, all right, which is really what this is going to say, all right, a to the m over n power. Again, that came out a little hard to read, but that's a to the m over n power is a to the m and the nth root of that. So your numerator is the exponent in your radicand, and the denominator of your fraction is the index. Okay, so to write these in radical form, x, that's x to the 3/7 power. Well, that is x cubed and the 7th root of that. And so maybe it's easier, or probably more appropriate to say the 7th root of x cubed. All right. What about this? Y to the negative 3 5/10 power. That's not a fraction. Well, so the first thing we have to do is make this look like a fraction. So negative 3 5/10 is negative 3.5. And now I can change that into an improper fraction. 2 times 3 is 6 plus 1. I can write that as negative 7 over 2. All right. So this would be y to the negative 7/2 power. And if we look at y to the negative 7/2 power, well, first of all, I'm gonna do a new problem over here. All right. If it was y to the 7/2, no problem. It's the square root of y to the 7th. That's what it would look like. And again, you can write that 2 in there if you want to. Now, what do negative exponents do? Making that exponent a negative, remember, reciprocates things. It flips it over. So it would be 1 over the square root of y to the 7th. That's an okay answer, all right? But we can't leave it like that. We have to rationalize that denominator, and I'm going to multiply top and bottom by the square root of y to the 7th. And so 1 times the square root of y to the 7th, let me section this off here, would be the square root of y to the 7th. And the square root of y to the 7th times the square root of y to the 7th would be the square root of y to the 14th power, because I add these two together, which would just be y to the 7th. All right, remember we talked about this. And that also kind of plays into what we're talking about. Remember, that's a 2, so this is 14 over 2. If we write that, using this fraction, so that'd be y to the 7th. So I get the square root of y to the 7th over y to the 7th. All right, and so now we have simplified that expression. So if I want to write these in exponential form, all right, so write them with an exponent. So I've got my numerator, my denominator, again, if they don't write it in there, it's a 2. This is a to the 5/2 power. Okay. And here, all right, so that b has a 1, all right, so this is b to the 1/5 power, but then I want to cube that, because notice this 3 is not inside, it's not part of the radicand. And now, so we've got this, but now I've got a property of exponents here. It says when I've got a power raised to a power, I can multiply these two things. So I can write that as 3 over 1. when I multiply 1/5 times 3, I get b to the 3/5 power. Okay. All right, so just this idea here to be just, make sure you can go from a fractional exponent to a radical expression, where that's the numerator of your fraction and that's the denominator. All right, so give these problems a try. All right, again, just practicing this, going back and forth between a fractional exponent and the radical expression. And then the next assignment we'll continue on with this. All right, so but I'll get these answers posted for you. Nothing to post on Flipgrid just yet. All right, we'll wait until day 2 of this. But let me know if you have any questions. Take care, guys.